Let's recall that the domain of a function is the set of all possible input values and the range of a function is the set of all possible output values. What I'd like to do in this video is show you a little bit about how to identify the domain and the range when you're given the function in the form of a graph. When you're looking at a graph, it's good to remember that we have two axes. So this is the x-axis, and this axis up here is the y-axis. When we talk about input values, our traditional input values are the x values, and our traditional output values are considered to be y values. And that correlates fantastically when you're thinking about a graph. When we talk about the domain and the set of as the set of all input values and the range as the set of all output values, keep in mind that when you have a graph, these represent millions and millions of points. We're not just, for example, talking about the point -4, 0 here, oops, and the point -2, 4 here. What we've got is we've got every single point in between here, fractionals, decimals, irrational numbers, everything that lies along these sets. And anything that actually lies on these points of our graph, up and down and back up again, represent input and output values. So because of that, it's often best to think about our domains and our ranges in terms of inequalities, especially when we're looking at graphs like this rather than isolated and individual points. So I've kind of got things written here. The domain is going to be the set of all x values in between here and here. The range is going to be the set of all output values, f of x, or you might see these written as y sometimes as well. So what you want to do when you're looking at a graph is really, you're kind of going to two-dimensional squish it when you think about things. So for example, if we're looking for the set of all possible x values, remember this is our x-axis that goes along here. What we want is the smallest x value that we see as well as the biggest x value that we see. So for example here, the smallest x value when our graph starts is here at -4. So that's the smallest value that we get. Then as we travel along the x-axis, notice all of these are values that are part of my function, and all the way until here. And then once I get to, this is 6, once I get to x equals 6 here, now there are no longer any input values anymore because the function no longer, or the graph no longer continues, so our function is no longer defined. So here we could say that our domain is all the x values between -4 and 6, and this is the mathematical way that we can write that using the less than inequality. For the range, we're going to do the same thing, except instead of looking at the values that are taken on looking from left to right, we're going to look at the y-axis. So we're going to be looking at this way and see what's the smallest y value that gets taken on and what's the biggest y value that gets taken on. In this case, the lowest that the graph ever goes is down here at y equals -1. So that's going to be our smallest value. And then the biggest value that it's going to take on is all the way up here. And let's see, this is 5, 6, 7, 8. So the biggest y value it's going to take on is 8. So we could write this as -1 is less than or equal to f of x is less than or equal to 8. Or you could use that by talking about the y coordinate value. So as we look at the domains and the ranges, these are the types of pieces that we're looking for. Let's look at just a couple of other examples so you can see some subtleties here in terms of what we may be looking for. Here we've got our domains and ranges written in table form, kind of a throwback to our last one. Remember, the biggest thing here is our inputs are x values and our outputs are our y values. The domain is all the possible input values here, 4, 6, 8, and 10. And that's going to be our domain. And again, a lot of times you'll see this written as d equals. Our range is going to be equal to all the output values. In this case, everything only has one output value. They all get mapped to 12. So our range is just the single value of 12. In this last example here we have another graph again. And so when we're looking at our domain, we're going to look at just the x coordinate values. So we're looking here along the x-axis. The smallest value, x value, that our graph takes on is here at -1, because that's where our graph starts. So that's going to be the smallest piece here in our x coordinate. So we need at the very least, we need to have a -1 for our x value. Now our graph is going to travel on here. Notice from -1, we're traveling along. We go past 0, we go past 1, we go past 2, and then here at 3, notice the graph does not seem to continue after 3, it stops. Now what's a little bit different here at x equals 3 is, notice here we have an open circle, where here we had a filled in circle. This has a really important set of meanings mathematically. The filled in circle means that you actually include that point. An open circle means that you want everything up to that point, but not actually including that point. So for example here, if I had x equals 2.999, my graph defines that point. But as soon as I get to x equals 3, my graph no longer defines that point. So because 3, I want everything up to 3 but not including 3, I'm going to use the weaker form of my inequality without the line underneath it. So here this means I want everything between -1 and 3, including -1, but not including 3. And that's the difference in how we can write those values. For the range, we're going to do the same sort of thing. We want to go, again, we're going to look for values that y lies in between. The smallest y, and our y-axis is the one up and down this way. The smallest value that our y takes on is down here at -5, but notice it doesn't actually take on the point -5 because we want everything that's coming down until -5, but not actually that point. So here I'm going to write that as -5 less than y. Then I want all my y values here get taken on, taken on, taken on, taken on here, and all the way up to 4 is my biggest y value. But 4 is a point on my graph. See, it comes up, touches 4, it keeps going. There's no hole in the graph there. So as I define my range here, I'm going to have with the -5 just a strictly less than, whereas with the 4, I'm going to have the less than or equal to symbol here because I do want to include 4 as a possible result in terms of my range. If you use function notation, the other way that you could write this is this, and it means exactly the same thing. My output values of my function are going to lie between -5 and 4, including 4.